Germany. We have to start on time. Huh? Okay, welcome to my talk about by the byte JNI. JNI versus FFM. FFM stands for Foreign Function in Memory API. Comparison, it's subjective comparison, I must say, so it's just my experience playing around with it. So, who am I? My name is Birgit Kratz. I'm a freelancing developer and sometimes a Spring Boot trainer. I mainly work in the Java backend, and I co-organize some meetups and Java conferences. You have my contact data here. So what do I want to talk about today? A little background story, how this talk came about. And I want to show you the JNI in a nutshell, how it works in the old days, what pains we have with that, and then I want to show the new days, the Foreign Function in Memory API, which is only available in ready status or finished status in Java 22. And then I want to show you an example with code, and it's a Sudoku solver project. So if you want to solve your Sudokus quickly next time, use JNI or Foreign Function Memory API. And just a short or a subjective assessment, what I find interesting about it. So, but first, some questions for you. Who has used JNI and back in the days, and keep your hands up if you enjoyed it. And who has heard about Foreign Function Memory API, and who has used it already? No, just one. Okay, good. So maybe something new to learn for you. Okay, my background story. Like nearly 20 years back, I had to use JNI. It was a Java application we wrote in a financial environment, but we had to use a financial core program, which was written in C. Already a long time developed, written in C, lots of business logic inside, lots of know-how inside. So we were first thinking about what can we do? We have a Java application, a C program. It doesn't work together so nice. And the first impulse was maybe rewrite the core, the business core in Java. But this was really no option in a way. And so we had to go for JNI. And I had the pleasure, since I back then was also a C or C++ developer, I had the pleasure to implement this JNI. It wasn't a pleasure, I can tell you. It was quite a pain, and I even wrote a generator to generate all the JNI stuff. I couldn't find it though, I would have shown you otherwise. Anyways, and then I read about this JEP 454 about the Foreign Function Memory API, and I was like, this sounds interesting, you have to try it, whether it's really less painful and what is better now. So, when you want to integrate with some native program, be it written in C or any other language, any other native language, you have like two problems to solve. How do you allocate native memory? Or off-heap memory, not taken care of by the JVM? And how do you call these native libraries or native methods or functions or whatever you call it? And the old ways to do it, to manage off-heap memory, was in Java. It's still valid though, you still can do it. You could use byte buffers. There is a byte buffer allocate direct, and you have to say how much capacity you need, and you then have to take care of managing this off-heap memory. And it's only restricted to 2 gigabytes of memory you can allocate. And it's only deallocated when the object garbage collector is kicking in, so you can't really control it unless you control it within your program. It's not, it hasn't got the convenience of the garbage collector we're used to in Java. Or you could use the unsafe API, and as the name already says, unsafe, better don't use it. But with unsafe, you can allocate like huge memory, off-heap memory regions, but it also gives you almost too much control about this memory. And you really have to take care of the allocation stuff. And you have to take care of dangling pointers maybe, and so you really have to know your way when you want to use unsafe. Yes, but rather not use it. And for the calling foreign functions, the old way, you only had the way by using JNI, Java Native Interface. And even the JVM uses JNI inside, because it calls all sorts of functions which are operating system dependent. So, how to use JNI in a nutshell? JNI allows you to declare these native methods. You find sometimes in your source code it just says native something something, and you don't find any implementation in Java, which also leaves you questioning, oh, where do I find the code for that? What does it do? If there is not a good documentation for it. And then it allows you to interact with the code in the native language. So you have to implement these native methods in a native language inside a shared library. So you have to go out of your Java ecosystem and somehow implement this native method in a native way. And this JNI just gives you the bridge, the bytecode bridge from your JVM to the native code. So you're still kind of, if you use native code, you're still platform dependent. Like, it's different when you run it on Microsoft or Mac or any other platform you have. And the JNI is part of the Java since Java 1.1, so quite early in the days you had this Java native interface already. And as I said, the JVM also used JNI. For instance, if you have these methods you want to call, or these classes, there are native methods inside these classes, and in the JVM, JNI code is written for accessing these methods. But I heard, last week I was in Croatia on a conference, and I heard that the JVM will be switching to foreign functional memory API using this one. But slowly but surely. And sometimes when you write an application and you want to do some deep learning stuff or graphic processing, you just have to use native libraries because they only exist in a native language. And so you have to somehow work together with these native libraries. And there's no way they will be rewritten in Java just for you to use it. Okay, so how does it go? You have the Java client that wants to talk to a native library. So what you do the JNI way. You, of course, as I said, you declare a native method in your Java code, and then you can use a helper program, Java C -H, to generate Java header, C++ headers for you, or C headers. Then you have this header file where all the native methods are inside, and then you have to implement this in a native language, in this case C++. And then you have to, out of these two down here, you have to declare a library, and this library has to somehow link to the native library, so it calls the native library you actually want to use. And then you have your Java client has to call the library you just produced out of these bits here. So you have to leave your ecosystem and implement something in C or C++ or any other native language, and then you have to tell your Java client, please use this library by a system call. But the way directly from the native method calling the native library, it's not possible. Okay. The problems here, you really need to have good knowledge of the other language you want to use. As a Java programmer, which is not always appealing, you have to know about the memory management in that language, and you have to take care of potential leaks, like allocating memory and never freeing it, or freeing memory too early and use it after it's freed, so it leads to program crashes without any chance of recovery in the sense. And sometimes you don't even know why what happens. So I want to show you a JNI example. What I have here is this Sudoku solver program is actually just, I got it from somewhere. It's in the README if you want to see it. There's the inspired, there's a nice GitHub repo, the algorithms, if you ever look for algorithm implementations. So there I found the Sudoku solver has a header file and some implementation, and the only interesting thing here is the header file. We have a solve method, and this solve method gets some struct where we input the Sudoku we want to solve in a flattened array way, and we just tell two parameters how many elements do we have, and it's like 9 elements, and with like 3 by 3 structure. So that's the 3 inputs we want to deliver. Now I have a project where I want to use it the JNI way. So what do I do here? I say, okay, I have a native method, and I want to input my board in a int array, 2-dimensional array, and get this solution back as just a 1-dimensional array. That's how I defined it, how I want to use it. So to implement, or to write an implementation for this method, I used to call Java C-H, and this produced something like this, the header file for me, for implementing. This is already, when I look at it, it's like, I don't really want to do that. Then I have to create a new project in C++. I called it Sudoku Solver CPP. There I have this header file again. Where is it? Here, the produce header file. And I wrote an implementation for it. And you can already see it's, yeah. I get some JNI environment here I can work with. I get some other input. And this is the two-dimensional array I get. But it doesn't tell me really that it's two-dimensional. I have to know it. And then I read all the data out and somehow get all the data. And then somewhere here, I call the solve method of the other the actual library I want to use. And then I get the solution back, and I have to somehow convert it back into an JNI int array because I want to have an array back, and I have to free memory and all that stuff I have to take care of. So it's, yeah, it's C code, and you have to work with these environments and these JNI methods and all that. So, and then you have to build a library out of that, and the link to the actual library is I've done here, I link it here. So don't ask me about C and C++, it's more than 20 years ago, I don't know shit about it. Okay, so then I have to go back to my Java project, where I want to use it, and where is, yes, it's here somewhere. And here I have to load the library I just created. And then I can use the call to my solve Sudoku method here. And then I can solve the Sudoku. So what do I have here? I have some Sudokus here. I just used the first one, and I can run it. And it hopefully solves it. Yeah, here's the solution. So this was the input over there. So tell me, is it okay? Is it correct? You could try later. Okay, so that's the JNI way. As I think it's not really pleasant to do, but it works. So now we have the foreign functional memory API defined in JEP 4.5.4. It's final since Java 22. So if you already work with Java 22, you can use it. You could use it before. It's in some experimental or preview state before that. And it's part of Project Panama. So now we have some concepts to learn about memory management with foreign functional memory API. We have something like arenas. So inside arenas, you manage memory segments, so-called memory segments, and the arenas are closable, and when you close an arena, all the memory segments are out of your reach. So the memory is freed. So you have like a deterministic allocation and deallocation of memory segments. And you don't run into things like out of bounds exception or use memory after it's freed because it's just not possible. The memory segments or the arenas, they have several ways to declare an arena: global, automatic, confined, and shared. They have different characteristics. You can look it up when the memory is freed and how it's done. So inside the arenas, I said we have memory segments. Memory segments can represent on-heap or off-heap memory, but inside arenas, off-heap memory segments are taken care of. And inside an arena, all the segments you have inside there share the same life cycle. So when the arena is closed, all these memory segments inside that arena are gone, automatically invalidated for you. And then you have something like memory layouts. They kind of describe the content of a memory segment. So you can, these memory layouts can be created for size and everything, and you can group them, or you have like a, yeah, you can, how to say that, you have different kinds of memory layouts, group layouts or sequence layouts for lists, or just value layouts for putting values in a memory segment, so you can build a hierarchy of a memory layout if you want to. And then you have war handles. These usually, if you just use memory segments with a memory layout, to put values inside, you have to give an offset of something, put the value here, but the war handles will help you with the offsets. So I tried to put it in a graphical way. So you have the arena, and inside the arena you have the managed memory segments for that arena, and then you have memory layouts, and the arena gives you allocators for memory segments, allocator methods, so you can create a memory segment based on a memory layout or based on a war handle, or both. Or you have these arena allocate from string methods, or allocate from any other value layout. So this is the way you manage the off-heap memory. And then, how does it work now? You again have the Java client, and you want to call a native library, but this time with foreign function memory API. So what you have to do, now you can actually load the library you want to use, not another one created by you, to your Java client. You can do it first, and then you have to do a symbol lookup for the methods you want to use. But this is also all inside your Java code, nowhere else. And then you get, for instance, a downcall linker if you want to call the C or C++ method. There's also an upcall handle if you want to call back from the Java class into your Java library. It's also possible. And then you just create this off-heap memory because you want to transfer some data. And then you just call the actual native library. That's it. It's all, you don't have to leave your Java ecosystem. It's all inside Java. So I can show you this example too. We still have the same Sudoku library. And now we implemented a call based on foreign function memory API. So here I linked got a load library for the Sudoku solver, and then I read in my board I want to have solved, and then I create the memory layout here. So remember, we had a struct with with the array we want to deliver and the sizes. I get some war handles here, so I don't have to know the offsets I want to call. Everything is in, and then I create an arena, and I create a memory segment based on my memory layout. I fill in all the data here into that memory segment, and then I call the invoke on the linked method. I got the linker up here, the linker to that method I wanted to call here. Look up solve and get me a linker. And then I get the solved array back and just read it back out, and so that's how it works. It still looks like a lot of code, a lot more, and you have to take care of all this memory layout stuff, and it's not that pretty yet. That's my impression, but it also works. So, as I said, this looks kind of lots of code to just call one method and getting the symbol lookup and the linker and creating this memory layout and getting war handles. Imagine it would be a bigger method or more than one method I wanted to call, so it's a bit of a boilerplate I have to handle here. But there's help. And the help is JExtract. JExtract is a separate tool, but it comes kind of together with the foreign function memory API. And JExtract just helps you creating these boilerplate stuff you don't want to take care of, you don't want to write yourself. But as I heard, it will not be included in foreign function memory API, so it will stay a separate project or a separate tool. And using this, I can show you how the code looks then. So if you get the sources from my repo, I have a README here. And there it shows how to call this JExtract. And what it does, it gives you like a helper class and a Sudoku class. And if you look here, I'm not always exactly sure where the memory. Oh yeah, here the memory layout is done in the helper class based on the lib you want to include. It generates all the boilerplate for you, which I've done by hand before, and the memory layout and some value layouts, and it's a lot more code than I've written, but well, it's generated, so. And then it gives you some kind of setter and setter methods to set values into the memory layout and all that. You can have a look here. I think it's not really nice code. That's what I think, but it works. You can, and when you get used to it, it's yeah, it's easy to use. You have all sort of helper methods, and somewhere here you call the solver method. We have to find we have to find it. So I use this thing constructed by JExtract. I don't have to get a linker myself now. It's just in the helper method somewhere. So I just read in the board I get an arena where I want to put the memory segments, and here I just have these helper methods where I can set the values inside the memory layout, and then I just call solve. And this is in the helper method, or in the helper class. Here you have all the nitty-gritty things, like it creates the memory layout for us, and the linker and everything. So it's much cleaner already. I just get an arena, put in all the data, and just call solve, and that's it. And it works just fine. Okay, so this is JExtract. My subjective assessment is both approaches are, of course, platform dependent because of the native character. You want to call a native program, which is platform dependent, so you don't get away from that part. And FFM, if you're not on 22, sorry, maybe you can use it from 19 onwards somehow. I don't know how much changes there have been, but if you're on 22 and you have to talk to a native program, use foreign function memory API. Because you can completely stay within your Java environment, and even you don't have to deal with native methods anymore. And there's no code for where can you find the code? Well, I think it's especially if you use JExtract, you have less code, because writing all the JNI code in C++ is also a lot of code to write, which you're probably not so familiar with. And I think using the memory segments, memory layouts, arenas and stuff, you have to get used to do it. But it's not that intuitive at the first view, but you get into it. I've done it, you can do it. And you don't have to worry about memory leaks and dangling pointers and all that thing. Okay. Maybe some inspiration. Have you heard about the 1 billion row challenge, which was done like beginning of the year? So I said that off-heap memory was only possible to up to 2 gigabyte, I think I said. And the challenge was to read in a file, like a really, really big file with 1 billion rows, and quickly processes in Java. And this was done by Gunnar Molling, and there is one solution here, this link here, where they use memory segments to read in this big file into memory all at once, and process the file and get the solution. And I think it was the runner-up, so second place, the solution, processing this file in 1.5 seconds or something. 1 billion rows of line, so also done with arena and memory segments. So just an inspiration, maybe. Reading in files. Okay, any questions? Yes? No, I haven't done. yes, I think with my small example here, it wouldn't be a lot of Sudokus, yes. No, I haven't tried that one. Yes. Mm-hmm. Does the system provide an unload library? I don't know. Yes. I haven't tried that. Okay. So here's the link to the slides, and there in the slides you find the sample repository links. I'll be here today until about 5ish, so if you have any more questions, you can find me. Yeah. Okay. So I wish you have a good lunch and a good rest of the conference. Thank you.